In this tutorial, we shall demonstrate how D+ can be used to calculate the scattering curves of objects located in proximity to each other. As you can see in the 3D graph panel, we start by adding a uniform hollow cylinder. To better see the model, we need to adjust the viewpoint and the level of details parameters. We then add a second layer to the cylinder. As you can see, we created a core shell model, having a second layer with a significantly higher electron density, compared to the inner core layer. As you may have noticed, the color of the 3D plot changes as you change the value of the electron density. In addition to the hollow cylinder model, we add a sphere model. At the moment, the sphere is located at the origin, and therefore, in the 3D graph, it is buried underneath the cylinder. Changing the value of the Y field in the symmetry editor pane is already sufficient to change the sphere location, which is now outside of the cylinder. We enlarge the sphere and position it above the cylinder. Now we are entering the parameters of the entire object, the sphere and the hollow cylinder, into the Suggest Parameters tool. We get a suggested grid size of 60, integration method of Monte Carlo, and convergence of 0.001. We insert the parameters. Click Generate, and view the generated curve in the 2D graph pane. We see we have some numerical issues. The parameters that were suggested by our Suggest Parameters tool are a first approximation, hence not always perfect. We try the Gauss-Kronrad integration method, and, as you can see here, Gauss-Kronrad integration method is indeed more appropriate. We have saved the generated signal, and then reloaded it, as a reference signal, as the red scattering curve. If we want, we can now change the orientation of the cylinder in the symmetry editor, for example, by setting the beta degree to 90, and recalculate the scattering curve for the new structure. We see that, when there is more than one object, the orientation of the objects with respect to each other directly affect the resulting scattering curve. The red curve is the loaded signal, the old structure, and the blue is the new one. We save the current state as a state file for future use, and close the software. We then reopen the software. As you can see, some of the parameters are saved between sessions of D+. Exactly which parameters are saved between sessions may change between different versions of the software. Now we open the saved state file, and the configuration we created earlier in the tutorial appears along with all the parameters that were used when the state file was created. We change the parameters to the original cylinder with the sphere above it, and calculate the resulting curve. As you can see, the new calculation overlaps with the earlier calculation, as expected. The blue curve is the new computed model, and the red curve is the earlier curve, which was saved and loaded. You cannot see the red curve because it is completely overlapping with the blue curve.